Hello, everybody. Thank you so much for joining us for this week's PAVE panel. We are going to get started very shortly. Before we kick things off, just a couple of housekeeping notes. A reminder that you will be able to find the recording of this panel, as well as all of our previous PAVE virtual panels on our YouTube channel. Just search PAVE Campaign or on our website, pavecampaign.org. So I would like to welcome you all officially to PAVE's 141st, if you can believe it, virtual panel. Today, we are going to be talking about some of the more unique environments where we are seeing autonomy. We're going to explore how AV technology is being applied in some of these contexts and what lessons really that they offer for the broader AV ecosystem and the future of autonomous vehicles. So our panelists today are Paul Benfield of Forterra, Pete Bigelow of Kodiak, and Anuja Sonalker of STEER. My name is Caitlin Magny Miller. I am PAVE's Communications Director, and I will be moderating the conversation today. And before we dive in, I want to give our panelists a chance to introduce themselves. So let's start with you, Paul. If you could just give us a brief intro on who you are, what you do, and who you work for, we'll go from there.
Great. Thanks, Caitlin. Yeah, thanks for having me. So Paul Benfield, VP of Strategy at Forterra, did a little over 20 years in the U.S. Army, and then when I got out, got into defense and dual use technology consulting and venture investing. And then I've been at Forterra now for about 2 years. And at Forterra, we develop autonomous mission systems for both military and industrial use. But importantly, we don't focus on just the vehicles. We're trying to close an entire operation, and so that's the autonomous mobility, the resilient communications, the sensing, the edge compute. All of that we've designed to be able to be deployed across a wide range of vehicle platforms and use cases. And so whether it's defense or commercial, really the bottom line is we're trying to help organizations execute operations faster and safer at the same time while reducing risk.
Fantastic. Pete.
All right. Thanks, Caitlin. I think it's important perhaps to point out for some of the audience, the last time I was on a PAVE panel, I think it was in my role as a journalist. And many may know me as someone who is a longtime reporter and podcast host who covered the autonomous vehicle industry and the future of transportation. But more importantly, today I am on the communications and public affairs team at Kodiak AI. We are a company that provides an AI-powered autonomous driving system that works in the physical world, doing tough driving jobs. We've deployed autonomous solutions across long-haul trucking, defense, and industrial applications, the latter of which I'm sure we can go into greater detail on in this panel.
Fantastic. All right, Anuja, take us home.
Thank you, Caitlin. I'm Anuja Sonalker. I'm founder and CEO of STEER Tech. And at STEER, we develop autonomous vehicle systems for places where transportation begins and ends. So the endpoints, depots, distribution centers, airports, military installations, and other industrial environments. So same, and a little different. And our technology is a bolt-on retrofittable technology onto existing vehicles, vans, tugs, utility platforms, and then orchestrated through our command and control system that allows customers to manage the vehicles, the missions, the operational data, and do one or many at a time. And my own background is automotive cybersecurity and safety. So we have always approached autonomy not simply as a vehicle capability, but as a complete operational system. So the objective is to help organizations improve safety, increase utilization and throughput, and automate repetitive vehicle movements without requiring them to replace an entire fleet or to redesign their entire, organization, operation.
Fantastic. So as you can see, we have a really great lineup of panelists doing some really interesting work here. And I want to dive in. I'll start with you, Paul. When many folks think of AVs, they might be picturing a robotaxi or sort of a traditional passenger vehicle. Can you describe a bit more about Forterra's work and how you're developing autonomous solutions for the defense and off-road space?
Yeah, so to really down to the brass tacks, we focus on dull, dirty, dangerous, right? And so how do you remove human operators from those things while increasing efficiency? And so in the defense side, that's basically every mission in the ground. So whether it's a medical evacuation or logistics or combat engineering, um, the goal is to remove operators from unnecessary risk. On the commercial side, similar, we don't work on public conveyances, ports, distribution yards, warehouses. What those two things have in common is generally unstructured dynamic environments, right? And so if you think of on road, you've got traffic lights, you've got lane markers, you've got rules of the road. You're in a container yard. Not only is that container yard changing as containers are moving around, um, it's a dynamic environment and oftentimes limited communications inside those, valleys of stacks of containers. And so there's a lot of overlap between unstructured environment where the autonomy has to be adaptive in real time, and a lot of kind of communications GPS difficulties. And so what Forterra does, specifically, we try to build a common autonomy architecture that can operate across many of those different vehicles and missions. And to Anuja's point, we don't want someone to have to go completely redesign their entire fleet or their entire operation stack.
Yeah, that's really interesting. And I appreciate the comparison you made to, the rules of the road that you have when you're operating on public roads, compared to operating in an unstructured environment. Certainly some challenges inherently there. Pete, turning to you, you mentioned Kodiak is well known for your autonomous trucking operations on public highways, but you have also recently expanded your operations into the Permian Basin. Can you tell us a bit about your work there and why private industrial and remote environments are a good fit for automated mobility?
You bet, Caitlin. As you mentioned, we have our ongoing autonomous work on public highways, where we anticipate going driverless on long haul routes by the end of this year. Very distinct from that, we have our industrial deployment in the Permian Basin, where we have already gone driverless. And just to be clear on what I mean by that, when we say driverless, we mean there are no humans in the cab. So we work with a company called Atlas Energy Solutions in the Permian. We started driverless operations there with them in December 2024. And as of March 31st of this year, we had 28 driverless trucks that are owned and operated by Atlas, but have the Kodiak driver installed. These trucks are utilized on lease roads. In the Permian, if you don't know it, is an area that's like the heart and soul of America's oil and gas industry. It's about an hour and a half to 2 hours west northwest of Midland, Odessa, which is maybe a nice way to say that it's really in the middle of nowhere. It's a desert-like environment, so it is a place where it's really hard for our customer to recruit, maintain a workforce of normal human drivers. So this area also happens to be one of the most dangerous to drive in America, if not the most dangerous. In a 5 county area, there's about an average of 200 road deaths every year. So our driverless solution is deployed in a place where it can improve safety overall. And for our customer, Atlas, it really kind of relieves some pain points as far as they are a 24/7 operation. And with a driverless workforce, so to speak, that they can count on, they can enhance their reliability, efficiency, productivity, and keep things rolling for their customers.
Yeah, really cool to hear how there's, both a workforce opportunity there as well as a huge opportunity, of course, from a safety standpoint. Anuja, turning to you, STEER works across a variety of industrial and logistics applications. Can you give us an overview of how STEER is leveraging autonomy in environments like depots and what problems you're solving?
Absolutely. And by the way, Pete, what a fantastic impact, right? These are the kind of stories that have to be told. Like the impact that you're having, it's way beyond autonomy. It's the impact that you're delivering for safety in the environment that you're operating. So fantastic there. Um,
Thank you, Nisha.
uh, yeah, Caitlin. So to your point, when we look at a depot yard, industrial campus, right? We look at an enormous amount of vehicle movement that is necessary, but not always productive. And I, in fact, believe that these are structured environments, not unstructured. They are structured because there are so many operational workflows. There are so many things. It just so happens that there's a huge mix of all kinds of things going on. So it may look chaotic, but they are fairly structured. And so vehicles have to be repositioned, staged, brought to loading areas, moved to chargers, taken for inspections, transferred between facilities, or even just moving, dropping, picking up things and to and fro. Right? These movements may be short, but they happen repeatedly every day. They consume valuable labor, operating time, cognitive load. And so those are the kind of vehicles that we automate. So we will automate the driving system. We will connect them through our command and control systems so that operators can now assign missions, supervise multiple vehicles simultaneously, and understanding what is happening along across those operations. So an important part is to note here is that we're upgrading, not replacing. So most of these fleet operators already own vehicles that are useful. They have a significant remaining life. So it's not necessary to purchase, an entirely new fleet in order to benefit from the technology operation. So we have now we have over 35 vehicles on the road. We have supported more than 200,000 autonomous runs, and these are inside of confined spaces. Remember that, not robo-taxi runs. So with a reported performance of 99.7% of safety, reliability, and 98.7% operational uptime, right? But I will tell you that after all of those numbers, the customers, they don't care about the autonomy for the sake of autonomy. What they actually care about is, are my vehicles there when I need them? Whether the dwell time has been reduced, whether my operational throughput has been increased, whether my employees have been redirected to higher value work, and whether the operation becomes more safe and more predictable, right? And that is ultimately what we provide. It's not a self-driving vehicle, but an efficient operating system for physical movement.
Yeah, well put. And I appreciate your comments about how you're, solving real problems here, not just creating technology for the sake of it. I want to look a little bigger picture here and address the group as a whole. What misconceptions do you find that people have about autonomy outside of maybe more traditional passenger vehicles? And anyone can jump in, or I will call on someone.
I'll go first since I've been going first so far. So a couple. The first is it's not ready, right? It's an early technology. We still get that a lot. We potential customers want to do, a whole bunch of prototyping, need to be really convinced. But the truth is, I mean, you've heard this conversation that these systems have been operating for years, both in the military environment and industrial environment. Um, we have we have systems operating in conflict zones right now in the real world. So the misconception that it's not technologically mature, I think, is probably number one. And the second is cost, right? It's expensive if you add autonomy onto the cost of an existing platform. And I think the error there is people are comparing an autonomous system with an old vehicle or a human driver in the vehicle. And really, what they should be comparing is the value created, right? To what Anuja was just referring to. What is the real value created in that? Because if you talk about fewer accidents, higher utilization, operating around the clock, reduce risk to operators, when you measure the cost of an operation versus the cost of just the equipment, the economics become much more compelling.
Anybody else want to weigh in?
So another misconception is that going autonomous means fully removing every person from the operation, right? There is a whole fixation on, is there a person, is there somebody watching, etc. And in practice, autonomy, it's not about removing every person from the operation. It's not about eliminating the humans, right? In practice, autonomy changes the way people are going to participate. Instead of assigning them a repeated task of moving a vehicle from one point to another, that person may be redirected to supervise a fleet, handle exceptions, right, edge cases, maintain the system, or manage a broader operation. Like, you are creating, in some sense, you're shifting the person's workload to something else, and you're creating a new responsibility here. So that's something that we often hear, oh, it's going to eliminate a job. No, it's not. So it's redirecting people to higher value work, and therefore you are actually streamlining operations better, and you have somebody thinking on their feet, and now you can actually raise your throughput.
And Caitlin, maybe I'll round this out. as far as our industrial deployment in the Permian goes, I think there's a big misconception that it's an easier environment to operate in than highways. And I would say it's different, but not necessarily easier, or both come with their own distinct set of challenges. And for one example, we operate on dirt roads that have an incredible amount of potholes. Like I can't even explain. There's no like public road parallel to the types of environments that we're driving, and you need to have some finesse on them when you're especially top heavy with 75,000 pounds of frac sand in the trailer. So it's different and distinct. That's one example. Another might be that unlike highways, at least the great majority of the time, like we're on dirt roads where we see two-way traffic quite a bit. In fact, that's the crux of the operation is we're always dealing with two-way traffic, and these are just different environments that bring their own distinct challenges.
Exactly, exactly. I can add to that real quickly. The another misconception we hear all the time is that low speed or private environments are easier. Automatically, they are easier, right? Yes, they may have fewer high-speed interactions, but they include tight clearances, irregular layouts, traffic patterns in various different directions, not just going straight, mixed pedestrian and vehicle traffic, uh, poor or no markings, changing inventory, and all kinds of and very little tolerance for disruption, right? So it's a different kind of hard, is how I'll put it.
Yeah, all really good points, many of which I had never considered. And this kind of tees up my next question, Paul. All of the environments we're discussing here differ pretty significantly from public roads, as we've established. Can you talk about some of the unique operational or technical challenges that you encounter when you're deploying autonomous systems in these settings?
Yeah, I mean the biggest one I think we've kind of hinted around it, but the adaptive nature of the environment, especially in combat environments, but and also in industrial one, not all of these places are going to be pre-mapped with a set routes, right? And so the autonomy has to be able to adapt on its own and then react to a changing environment that is not pre-mapped. We can certainly operate in those environments that are pre-mapped. That makes it, I would say, objectively easier. But to their point, it's just completely different environment when you don't have I'm in DC, Northern Virginia, and I see the Waymo cars driving around right now. They're mapping all of the streets. They'll be doing that for a long time before the first Waymo car is around. We don't have that luxury in some of the environments that we deploy our systems to. So I think it's probably, the biggest differentiator is the adaptive environment. And then the requirement for on-edge compute because of some of the communications limitations we have in some of our environments. Um, you know, we can't assume that we can talk back to a cloud and get updates. So some of the software engineering and the compute hardware are designed for those particular challenges.
Yeah, really interesting. Um, Pete, we have talked a bit about this already, but I want to dive into it a bit more. Workforce development has been a big discussion point in the automation space, particularly in the context of autonomous trucking. How would you say workforce needs differ in some of these more specialized applications compared with traditional transportation?
Sure. I think I'm going to back into my answer to this one a little bit, Caitlin. Um, Back when I was a journalist, I thought the most exciting thing or most interesting thing about autonomy was that you have a vehicle, be it a robotaxi or truck, going from point A to point B, right? And that was the thing. But seeing things from the inside, I think I now have a much better understanding that what happens at point A or point B is essential to the overall success of autonomy as a business, which is a roundabout way of saying that, at your launching and landing zones, we are, just as Anuja described earlier, I think, creating new kinds of jobs that are higher value jobs with workers who ensure like seamless and safe departures and deliveries of trucks and their goods. These are workers who can conduct inspections, And by the way, as a side note, like you're really enhancing safety when you're inspecting 100% of your deliveries, which is, far greater than what we have today. And then also as far as job creation, like there's new kinds of jobs in operations centers that monitor the trucks. So I think that there is this shift to higher value work, new kinds of jobs being created. And let's not forget that this is all a backdrop to a driver shortage in America that still runs in the tens of thousands of truck drivers. So we find our customers across long haul and industrial applications alike, both looking to autonomy to take on new business and expand the routes that they're already running in ways that they otherwise could not. So they're creating value throughout their businesses that leads to further job creation.
Yeah, definitely some good points. And it sounds like there's a real opportunity here to supplement some of that labor shortage with automation and in turn benefit from some of those safety advantages, efficiency advantages, et cetera. So absolutely. Switching gears a bit here, Anuja, we talk, or I think there's a lot of discourse around public agencies, working together with some of the more public road deployments. But what role do public agencies play in supporting innovation in these more specialized environments?
Um, a lot. So I think, contrary to what may be obvious, that, okay, these are private closed control environments and there is really no role for regulation to play in these unregulated environments. Yes, yes, and yes. But public agencies can play several important roles, right? First of all, um, many public agencies themselves are operators of large fleets, depots, airports, military installations, public works, ports, you name it. That means they are not simply regulators of autonomy. They can also be sophisticated early customers, right? These agencies can provide real world environments in which these technologies can be evaluated against a mission goal. So outcomes, thinking of outcomes, not just prescription of rules. The most valuable demonstrations are not just stage showcases, right? It's about control, you defining the operational need, the environment, establishing safety and performance guidelines and measures, and then streamlining and operating these use cases in that environment to be able to then produce KPIs, measurable, put those things out. And um, and I will say that the Department of War has now overhauled itself and started doing this, but the public agencies also, they can address what I call the pilot to procurement gap. Right, there are so many successful demonstrations the industry has done, but the contracting, budgeting, the government procurement mechanisms, they have not scaled in that direction, and they're not as mature as the technology has gotten mature. So public agencies can actually create outcome-based solicitations, establish more cleaner pathways from pilot to production, and allowing modular technologies. So it's not the one answer, one technology is the answer end to end. You may be hand holding multiple, something at the endpoint, something in the long haul, something in the middle mile, etc. You can string them along, but you can absolutely do that. And I think the public agencies have an important role to play there. And one last thing I can add there is, safety and cybersecurity, right? So these agencies can support common safety, cybersecurity, and performance expectations without being prescriptive in nature towards any technical architecture. So that's another role that public agencies can play.
Yeah, so as you said, there is a lot that they can do. Sort of in a similar vein here, Paul, many of these off-road or more unique deployments are taking place outside of the public eye. How do you communicate their value to policymakers and also then the broader public?
Yeah, I mean, I think Anuja really hit on it earlier. I mean, it's focusing on outcomes, right? This is not autonomy for autonomy's sake. We're not just, building a new cool toy. This is about operational outcomes. And I mean, I'll just one recent when we had an article come out when we do have systems deployed in Ukraine, and we've lost an autonomous system in combat. There's a photograph of a completely burned down, vehicle that had completed hundreds of resupply missions. That burned down vehicle had no operators around it. No one was injured. And that image illustrates the value, way more clearly and succinctly than talking about autonomy algorithms and, advanced sensors ever could. And so really it's just getting people to understand that the autonomy, when they see it solving problems, that's going to really communicate more than a new flashy video of something driving cross country.
Yeah, really well said. Um, Pete, gonna kind of build on this theme here. One of PAVE's biggest areas of focus, as you know, is building public trust and acceptance in automation as a whole. How do you think some of these specialized applications can help accelerate broader public acceptance of AVs?
Yeah, I think it's not dissimilar from robotaxis, and I always go back to seeing is believing. And when people have that firsthand experience with automated driving technology, it really is kind of a catalyst in swaying opinions and getting them on board to see that this is safe and efficient. A little bit different on the autonomous trucking side in that members of the public are not in our Class 8 trucks going for the ride themselves, but it does kind of go back to like in the Permian, we have employees working around the trucks, from our customers. Same with our highway deployments. And motorists see those on the highway as well. So the more that they see us driving in safe, conservative manner, I think that that goes a long way in showing both members of the public and others who are other stakeholders that are interested that this is a technology that's safe, mature, and ready for the road.
Yeah, definitely. And to your
Has to
point, in a
start at the task level, before it is granted at the technology level. So people, specialized deployments can help build that trust because the benefit is visible, it's intuitive. You can run these deployments and build evidence over time, operating hours, completed missions, interventions in a more visible, confined space and transparency, right? Trust is created by it's not created by announcing that the technology is now safe. It is earned through transparency, repetition, and demonstrated performance and showcasing that data. So
And I would say it's interesting kind of thought experiment. How is operating around autonomous systems different than operating around a team of humans in terms of building trust? It comes down to repeat what Anuja just said, it is repetition and increased complexity. And so if you're on a sports team, you start with the basics and then you start trusting, your teammate to the left and right to be able to do more increased tasks until you build that confidence. And so agree with what Pete said. The more people see these things operating safely and doing more and more things across the spectrum of load handling and transport and unloading and safety operations, I think that the trust is going to be built organically, but you have to have, go back to Anuja, we got to get beyond the pilots so that more people see these things operating at scale so they can see that the complexity and the repetition has actually occurred. And that's how you're going to build trust.
Yeah, absolutely. We just have a couple minutes left here, so I'll end with one more question for you, Anuja. Kind of in the same vein of what we've been talking about here. A lot of folks see mining, defense, depots, et cetera, as really completely separate from passenger transportation. Where do you see the greatest overlap here, and what innovations developed in these environments do you think are most likely to influence the future of on-road autonomy?
a great question, and especially what a great closing question, Caitlin. Thank you. I mean, this helps bridge the entire big autonomy picture, right? The environments may look different, but many of the underlying problems are remarkably similar. Right? We've spoken about it already. Every autonomous system, now let me rephrase that though. Every autonomous system has to understand its surroundings, make safe decisions, manage uncertainty, communicate its status, and respond appropriately when conditions move outside the expected operating domain, right? So specialized operations are advancing several capabilities that will directly transfer to broader transportation, on-road transportation. And the first is, of course, perception, robust perception. So all the applications, mining, defense, industrial operations, They have to deal with dust, poor markings, irregular surfaces, weather condition, mixed usage, vibrations, etc. And these environments teach autonomous systems how to operate when the world is not clean and not perfect. And then the second is the remote assistance and fleet orchestration, right? The future is not just going to be one intelligent vehicle. It's going to be groups of vehicles being assigned work, monitored, maintained, coordinated with people and coordinated with infrastructure. They're also going to be heterogeneous kinds of vehicles, like different mixes of vehicles, not just the same brand and same type. Um, so being able to understand that safety and cybersecurity, right? These industrial and defense applications, these customers, they demand evidence that the system can fail safely. It can protect command and control functions. They can maintain control of the vehicle throughout its life cycle in very difficult or austere environments. And they are teaching us also, finally, how autonomy in real operations operates, right? So the passenger transportation, I'll say that will eventually, and we are seeing that now, they're eventually going to need the same integration with charging, parking, maintenance, dispatching, infrastructure, and how they're struggling with that part of it, right? The endpoint today. Most of the edge cases you see today in the robo-taxi world are because of these unseen edge cases, smoke and traffic, accidents, etc., chaos. In other words, I could define them as chaos that is different from what they were designed and trained to operate, which is something that inside depots and yards, and we excel in that. So can you imagine the mining, the learning that these systems, these endpoint focused systems, how much terrific learning they have done, and that can be shared and applied to these other on-road, companies. Like they could absolutely benefit from that.
Yeah, really well said. There's obviously a lot of overlap there and a lot of learnings to be taken, across the industry. But we are out of time. So, Paul, Pete, and Anuja, thank you all so much for taking the time to share your expertise today. I really appreciate it. Like I said, we will be posting the full recording of this panel on our YouTube channel and our website at pavecampaign.org. So, check that out later today. And thank you to everybody who attended. We appreciate your participation.
Thank you, Caitlin.
Thanks, Caitlin.
Thank you, Caitlin.